Okay, here we have a skier, and the mass of the skier is 78 kilograms, which means that the weight of the skier is going to be 78 g newtons, acting vertically downwards as usual. And that skier is being pulled at a constant speed up a slope. Inclination is 12 degrees, so that's here. Um, and the force that's pulling the skier up the slope is size 210 newtons, acting at 20 degrees to the slope. So I'm going to put that in here. So we've got 210 newtons acting at an angle of 20 degrees to the slope. So we've got an angle of 20 degrees there. If we look at any other forces which are acting, well, we're not told this, but there's always going to be a normal reaction, so the normal contact force between the skier and the slope. And we've also got a frictional force, which we're told. Now, the direction of the frictional force, friction always acts against the motion. She is being pulled up the slope by the 210 Newton force, which means that the frictional force must be acting down the slope in that direction. Now, it's important to realise here is that the acceleration is equal to 0. And if the acceleration is 0, it means that the forces which are pulling her up the slope must be exactly equal to the forces which are pulling her down the slope. Okay, so let's have a look at those forces. I'm going to put some more angles in first. This angle here must be 78 degrees. And what I usually do here is put in several other angles just to make life easier for myself. I might need them later. It's a useful habit to get into. Okay, this line is extended. This angle here then must be 12 degrees because you've got a right angle here. If I put in a horizontal, then this angle here must be, again, the 78 degrees. And this angle here is, again, the 12 degrees. Okay, so let's look at the forces. The forces acting up the slope are going to equal the forces which are acting down the slope. So pulling her up the slope is only one force. It's this 210 Newton force. And what's actually pulling her in this direction is the component of that force which is acting up the slope. And that's just going to be 210 multiplied by cos 20 degrees. So the component, that's the only force which is tending to make her go up the slope. In the opposite direction, so I'm going to put these equal to each other because the forces acting up the slope are going to equal the forces acting down the slope because the acceleration is 0, which means that the overall force, the resultant force pulling her up the slope must be 0. So tending to go in the opposite direction, you've got the frictional force, which we don't know, and you've also got acting down the slope, the component of her weight, which is acting in the direction down the slope. In other words, that's going to be 78 g cos 78 degrees. Okay, so if we then want to work out f, all we've actually got to do is 210 cos 20 minus that 78 g cos 78. Don't forget g is 9.8. And if you work that out, it comes out as 38.4 newtons. Okay, we're now asked to calculate the normal contact force between the girl and between the skier and the slope. In other words, the normal contact force. Now, what we have to realize here is that because the skier is not lifting off the slope, and neither is she moving into the slope, she's moving down the slope in this direction, the normal reactions of the force which is tending to make her pull away from the slope must be exactly equal to the force which is making her go towards the slope. In other words, that normal reaction must equal the component of the weight which is acting in this direction. So the force acting in this direction for her must exactly equal the force which is acting in this direction, because she's neither lifting off the slope nor moving into the slope. So if we work those out, the normal reaction is going to equal the component of the weight which is acting in this direction. In other words, 78 g cos 12 degrees. Aha. Okay, ignore that last bit. I forgot about the force that's pulling her up the slope. Same idea though, the forces which are forces this time, I've just realised because we've got this one as well, the forces which are pulling her away from the slope must equal the forces which are pulling her towards the slope. Okay, acting away from the slope, you've got all of the normal reaction, and you've also got the component of this pulling force, which is acting in the same direction as R. And that's going to be 210 cos 70 degrees, because this angle here is 70 degrees. Okay, so R plus 210 cos 70 is going to equal the force which is tending to make her move towards the slope, and that's going to be the component of the weight multiplied by cos 12 degrees, because this angle here between the weight and this direction is 12 degrees. And if we work that out, we end up with R equals 676 newtons to 3 significant figures.